Hello, so let us try to look at number 3 from year 2010, Form B. Here first, let us try to read this question a little bit. This is a table here. We are looking at above ground swimming pool in the shape of cylinder with radius of 12 feet and height of 4 feet. And pool contains 1,000 cubic feet of water at time t equals 0. So this will be the initial condition which we have to know. And then water is being pumped into the pool. So P of T is the rate of water being pumped into the pool here. Now, at the same time, water is leaking from the pool. So this is a rate once again of how much of water is leaking in this format. All right. Then let us try to look at A first. Use the midpoint Riemann sum with 3 subintervals of equal length to approximate the total amount of water that was pumped into the pool. Now that means we just have to integrate this one. So basically for 0 through 12, so we want to integrate from 0 through 12 of P of T dt, but we are using the midpoint Riemann sum. Then in this case, what we're going to be doing is this. This can be the first rectangle where the middle term, meaning 2 and then 46, becomes the first value of the height. Second one is 57. This will be the third one. And you can see that the interval will be in 4. So we end up getting 4 times 46, because that's the middle value here, plus 57 plus 62 becomes our answer. So then let's try to look into that using our calculator. So here we have 4 times 46 plus 57 plus 62 becomes 660. All right. So we get 660. Now in this case, this will be cubic feet of water has been pumped into the water pool. Alright, let's look at part B. Part B is we need to calculate the total amount of water that leaked out. That means 0 through 12 for R of T dt, which we can see from here. Then we're going to go for y equals, here we have 25 and e to the negative 0.05 t. So in this case, we're just going to put x. Alright, and then we're going to have window as 0 through 12. And once again, zoom fit, which is equal to 0, will get us a nice picture. So that's basically what's happening. Alright, then we can calculate the integral number 7. Lower bound becomes 0, upper bound becomes 12. So it's approximately 225.59 feet. That amount of water that has leaked out during that time. Now, number C, use the result from part A and B to approximate the volume of the water in the pool when t equals 12 hours. And then to the nearest cubic foot. So we end up getting part C was at the end when R instead of using R, we can just call it as amount of water at the end of t equals 12. There was originally 1,000 cubic feet of water, but we pumped in 660 but we subtracted 226. How about that? To the nearest integer. Then this becomes our answer. 1000 plus 660 minus 226. So 1434 cubic feet becomes our answer. Alright, let us try to go for part D. Find the rate at which the volume of the water in the pool is increasing at time t equals 8. Now, so we need to figure out dV dt and how fast is the water level in the pool rising at t equals 8. That means we are looking at dH dt. So let me use a different color for a second. Part D. dV dt is simply P of t, how much we are pumping into the water, and minus R of t, which is how much of water is leaking. But since we are looking at when t equals 8, we are looking at here P of 8 minus R of 8. What is P of 8? We can figure that out right here. 60 minus R of 8. We can figure that out from here. Since this one was equal to R, we can figure it out. The value, number 1. R equals 8. That's right. We end up getting 16.758. 16.758. That's basically what we end up getting. Then dV dt, therefore, will be equal to, oops, okay, alright, sorry about that. So dV dt becomes subtraction between these two. So we have $60 minus the y value, which will be 16.758. So 43.242. And then in this case, this will be the cubic feet. But we are looking at dH dt. So since V is equal to pi r squared h, where r and pi are constant, what we end up getting is dV dt will be equal to pi r squared dH dt. Once again, that's because r is constant as the height of the water moves back and forth. Then we realize that this one was equal to 43.242, and then we need to divide that by pi r squared, which is pi, simply r was equal to 12 square, I believe, right over there. That must be equal to dH dt. Let us try to calculate this one. So we have divide by pi times 144, which is 12 square. Then that's what we end up getting. So therefore, dH dt would have been equal to 0.0956 feet. And that's basically what's happening. Alright, I'll see you guys later. Have a nice day. Bye.